Welcome back. Welcome to part 2 of the matter, energy, and nutrition video. Let's talk about specific heat. So specific heat, it varies from substance to substance, so it's different from one substance to another. And it's the amount of heat that raises the temperature of 1 gram of material by 1 degree C. And we use that in this equation right here. And so heat equals specific heat times the mass of our material times our change in temperature. So specific heat's used to calculate the relationship between change in temperature and heat, or energy in other words. And so in the SI system, specific heat will typically be listed in joules per gram degree C, and metric system will be in calories per gram degree C. So you might actually see either one of these in a problem. They're both quite common. And so right here we have a list of values of specific heats, and I want to draw particular attention to water. You'll notice that water has a extremely high specific heat value in comparison to other substances. And you might also notice that it has a value of 1 right here, 1 calorie per gram degree C. It's actually used as one of the bases of the metric system, this energy right here. So 1 calorie per gram degree C is the specific heat of water. And most other materials, as you can see, are significantly lower than that. So here we have a simple problem. How many kilojoules are needed to raise the temperature of 325 grams of water from 15 degrees C to 77 degrees C? So let's underline our data points there. So we're going to use these in order to find our delta T, or a change in temperature. And here is our mass of our water. And the other quantity that we need in order to solve this problem is going to be the specific heat. And we can refer back to the previous page. Specific heat of water, let's use joules here, is going to be 4.184 joules per gram degree C. So let's go ahead and solve this problem. We're going to use our specific heat equation, and we are going to first find our delta T by taking our final temperature minus our initial temperature. We end up with 62.0. So notice that we have 1 decimal place, and again 1 decimal place. And so we can only know our answer to 1 decimal place. So we're using our addition, subtraction, sig fig rules here, which are based on decimal places. And again, it's final minus initial temperature. And so what we see here is a positive value. That means we're increasing in temperature. Your delta T should be negative if you're decreasing in temperature. All right, so now we substitute in our values. So here's our mass of water that's given in the problem, and that's known to 3 sig figs. 62.0 is our change in temperature, our delta T that we just calculated. And using total sig figs here, we have 3 total sig figs. That 0 is significant because it's to the right of non-zero digits in a number with a decimal point. Right here we have 4.184 joules per gram degree C. You could argue either way, but I think a lot of people would argue this is one of the bases of the metric system, therefore it's exact. But you know, I probably wouldn't dock you points on a quiz or exam if you said that it was measured. It's kind of a tricky one there. And then this conversion right here from joules into kilojoules is also exact because those are in the same measurement system. So we know our answer here to 3 sig figs. So that is our 325 times 62.0 times 1.84 divided by 1,000. And grams cancel right here. Degrees C cancel right here. Joules cancel right here. And we end up with kilojoules, which is what the problem asks for. So 84.3 kilojoules. So I'd like you to now pause the video and please complete questions 4 and 5 in the activity. All right, welcome back. We are almost done. So let's finish out our last topic, which is energy in nutrition. And so I just want to remind you guys that calorie with an uppercase C is different than calorie with a lowercase c. In the US, we typically use calories with uppercase C to show energy in food. In other countries, it's often shown as kilojoules. So in foreign nations, usually it's going to be kilojoules. In the United States, it's going to be calories in uppercase C. And again, as a reminder, 1 calorie with uppercase C equals 1,000 of these little calories. So 1 food calorie is 1,000 little calories. So right here we have the 3 macronutrients, and we call them macronutrients because there's a lot of them in foods. These foods contain a lot of these materials, and they're calories per gram. So carbohydrates contain just over 4 calories per gram, and so notice it's big calories here, uppercase calories. Fat contains almost 9 calories per gram, so 8.8, and then protein contains 4.1 calories per gram, so similar to the carbohydrates or sugars. Now, fat has a lot of energy in it, and that makes sense because our bodies actually use fat to store energy. So how do we use these? Well, we have an example problem right here. So in our example problem, we have a cup of whole milk, which contains 12 grams of carbohydrates, 9 grams of fat, and 9.0 grams of protein. So we're going to take these 3 values and use the conversion factors on the previous page to convert those from grams of whatever nutrient into calories. And the way we do that is shown right here. So we have 12 grams of carbohydrates, and so for every 1 gram of carbohydrate, there's 4.1 calories. So that corresponds to 49 calories from the carbohydrates contained in that cup of milk. And then we have 9 grams of fat, so we take our 1 gram of fat corresponds to 8.8 calories, so we end up with 79 calories. This again is to 2 sig figs. So 79 calories in the fat that's in that milk. And we have 9 grams of protein using our conversion factor again, that translates into 37 calories. So what we're going to do is we're going to sum these all together, and we're going to use our addition subtraction rules, and so these values are all known to 0 decimal places. So the ones digit is known, but none the tenths or anything like that. And that means our answer can also be known to 0 decimal places. So we actually gain a sig fig overall when we add these together, though we keep the same number of decimal places. So go ahead and go now and complete question number 6 in the activity. And congratulations, you're just about done. Thanks. Bye.